My name is Tristan Strickland, and today I'm going to be talking about charges, conducting, and insulators. Before we talk about how to give objects charges, we need to lay some foundational principles in order to understand those things. So first, something we'll just go over really quickly is like charges repel and opposite charges attract. So the two main subatomic particles that we'll be talking about are electrons with negative charges and protons with positive charges. When you have two like charges come together, such as electrons, they repel each other. And when you have two opposite charges come together, they attract each other. When you have an atom with it at equilibrium, meaning there's an equal number of protons as there are electrons, then you have a neutral particle. When you have an imbalance of charges, in this case, if we have 3 protons in the nucleus and then 2 electrons on the outside, then you have a net positive charge. So one real world application that you can see is when you have 2 balloons with an excess of electrons, meaning they have negative charges on them. What you'll observe is that they will repel each other and exert forces in opposite directions. And this is what causes that repelling force. So now that we understand the concept of charged particles, we're going to dive into conductors and insulators. So conductors are materials that allow for the free flow of charged particles through them. So in this example, we send a bunch of electrons through this material that is a conductor, and when we do so, the electrons are allowed to freely move through them, similar to like a sea of electrons. And the reason is because these atoms they have free orbitals and allow for free movement of electrons through them. Some examples of conductors are most metals such as copper, gold, and silver, as well as salt water. Now the difference here is the kind of charged particle that flows through them. So with metals, typically you have electrons flow through them, as mentioned in this example. But with salt water, on the other hand, we have ions move through them. And so these are charged particles such as sodium chloride, hence the name salt water. And these are actual atoms with charges that will flow through the salt water. The other type of material we have are insulators. And these are materials that hold tightly to their charged particles and resist the flow of particles. So in this example, the reason it would be difficult to send electrons through this material is because these atoms hold tightly to the electrons, unlike the conductors, and they greatly resist the flow of electrons through them. Some examples of this are rubber, wood, and glass. Now, real-world application that you'll see with insulators or conductors are wires that you'll find in your appliances at home. So what happens is you have a conductor, typically copper, that allows for electrons to flow through them freely. That way you can power appliances at home, such as your toaster. And around those wires, we'll put a rubber material around them in order to insulate it from the surrounding environment. That way we can safely handle them. Alright, so now that we have a basic understanding of charges, conductors, and insulators, we're going to go ahead and talk about how to transfer charges. So in our first example, we'll talk about conductors. In this example, we have 2 conducting materials. One has a net negative charge on it, while the other one is neutral. So with conductors, it is relatively simple to transfer charges because the atoms hold the electrons relatively loose to the nucleus, and so all we need to do is touch them together. When they make contact, these electrons will be transferred into this neutral object in an attempt to reach an equilibrium. Now, in this case, an equilibrium is defined as these 2 objects having the same net charge. And so once enough electrons are transferred, the transferring will stop, and these 2 objects will now have charges on them. And in this way, we're able to transfer this negative charge onto this conductor. So with insulators, it takes a little bit more energy because the electrons are held so tightly to the nucleus of insulating objects. Typically, the energy required is given through friction. So you've all likely seen examples of this as you've walked on the carpet. When your rubber shoes are rubbing up against the carpet, it gives these electrons energy to be transferred onto your body. So when they're transferred here, you have been given a negative charge. And these negative charges, you can see evidence of these negative charges on your body when you go to touch a metal door handle. When you do this, these charges are discharged, and you see a little bit of static electricity produced. Now with induction, this is the third way to transfer charges. And what you do is you have two Van de Graaff balls, which are conductors, and initially they have a uniform charge in them. But when you bring an object, such as a positively charged material, close by but not touching, what you'll have is the electrons migrate to this side because they're attracted to this positive charge, while the positive charges stay over here. And then when I separate these objects, you're left with one Van de Graaff ball with a negative charge on it and one with a net positive charge on it. So one real world application of charging objects is something you guys have all seen and done before, and it's with your printer at home. So with inkjet printers, you have a nozzle that will shoot these very fine ink particles through an object. This object then gives these ink particles a charge, and with these now charged ink particles, they pass through two conducting plates with certain codes from the computer that will then direct them onto the paper in very precise forms, and thus you're able to create very precise images and words on your